Hey, welcome back. So in this lecture, let's understand about the gyroscope sensor and why it is used, and we will also see when to use gyro and when to use accelerometer. All right. So as accelerometer measures the acceleration on the axis x, y, and z due to the acceleration forces acting upon it, the gyroscope measures the rotational movement across its axis. Okay. That means if I keep the gyroscope in my hand and if I start running on the x-axis, then the gyro ideally should not show any readings over the x-axis, okay, unlike the accelerometer, even though the vibrational forces are exerted on the sensor. But if it is accelerometer instead of gyroscope, then we should see some readings coming out from the sensor across the x-axis. Okay, so that means I am just running on the x-axis. I am not rotating on the x-axis. If I rotate on the axis like this, then the gyro will output my rotational speed on that axis. That means how fast I am rotating on this axis, okay, in terms of degree per second. So the unit in this case, I mean how fast the object is rotating, okay, is measured in degree per second. So let's say in this case the object may be rotating at 5 degree per second. So the gyro will output some raw values, okay, which correspond to the object's rotational movement. Okay, so in gyro also you will get some raw values, okay, and that means some numbers, and your job is to convert them into degree per second. Okay, otherwise it won't make any sense, right? Now let's say the gyroscope sensor is quietly resting on the table, and now what do you expect from the gyroscope sensor? There is no rotational movement across any of these axes, right? So ideally you should be seeing 0 0 0 in all three axes. Don't worry, we will confirm this when we do experimentation on the real sensor, okay, that is our MPU 6050 sensor, which we are going to interface in the next lecture. Okay, now when to use accelerometer and when to use gyroscope. Now let's take an example of three-dimensional movement of an airplane. Okay, there are three types of movements of the plane. Those are roll, pitch, and yaw. In the first picture, okay, the airplane is tilting over the x-axis, right? So that's called as rolling. Okay, this actually gives the impression that the airplane is rotating over the x-axis. Okay, so because the tilt is happening on the x-axis. Okay, and take a look into this picture here. Okay, so here the nose of the airplane is going up and down, right? Okay, so that means if the plane wants to go up, then it will vary its pitch angle to upward, and if the plane wants to go down, then the nose of the airplane will go down. Okay, so that means by varying the pitch angle, the airplane can go up or down. So this picture actually gives the impression that the airplane is trying to rotate on the y-axis. Okay, similarly this is actually yaw, that is the airplane's nose is going left and right, okay, which gives the impression that it tries to rotate over the z-axis. Okay, now let's say the aircraft wants to go down. So first its pitching angle must be varied, right? That means the nose must start pointing towards the ground. Now how do you measure by how much angle it should pitch? Okay, because you cannot pitch randomly, right? You should pitch by some angle, right? And how do you decide by how much angle it should roll, etc.? Just imagine this can be your quadcopter. So in those cases you can use gyro sensor to measure the rotational angle of the object for a given axis. You cannot use accelerometer in this application, right? Why? Because it's a very dynamic system. There will be huge vibration forces on this aircraft, and your accelerometer readings will not be accurate. I mean, you cannot just filter out those values from vibrations and those values from real angle tilt, isn't it? Just imagine your quadcopter is tilting and its fans are making huge vibrations. The readings you get from the accelerometer represent G-value variation both due to the tilt as well as due to the vibrations. So how do you filter out vibrations? Right? So that will be very difficult. But if you use gyro, okay, then gyroscope will not be affected by the vibrational forces acting upon it, because it just cares about detecting rotational movement on the given axis. Alright, so that's the difference between accelerometer and gyroscope. So the gyroscope you should use in a dynamic systems where you want to measure the rotational movement. Okay, of course you can also measure the tilt angles etc. using accelerometer. You can do that, okay, and we are going to do that in the next coming lectures, okay. But once the accelerometer is deployed in the vibrating body, then the vibrational forces will make accelerometer to emit random values, and which won't make sense if you want to calculate the real tilt angles etc. So use the accelerometer when the body is static. Okay, the body should not be moving. If you want to use the accelerometer to measure rotational angle or tilt angle etc., okay, then the body has to be static. Okay, alright, so now enough theory explanations, and now let's explore one practical sensor called MPU 6050, and we will interface that to our Beaglebone Black hardware, and we will do some experiments, and we'll also explore its datasheet to see some of its important specs. Okay, great. So feel free to post your doubts, and I will see you in the next lecture.